Alright, welcome back. So I've decided that what we're going to do now is we're going to move towards implementing macros. And to start with that, we'll do the syntax quote operator, and if we have time we'll add these other unquote splicing and unquote, actually they're reader macros. So let's show you how these work in Clojure. We already have quote. Well, back quote is very similar, except say we have this x variable. Back quote lets you do something like this. This is the unquote operator, the squiggle. So we saw that, and then we say that, and what that's going to result in is it's going to quote that value, but the unquote operator tells us to evaluate the x and put that in there. So you'll get that. And unquote splicing is similar in that it lets you put a list in here, if I remember right. So let's make a list of 1, 2, 3. And now if we do 1 and then we say squiggle at with y 5, it's going to put the list, evaluate y to 1, 2, 3, which is a list, but it's going to splice it in there. So it's going to remove all the elements from the list and put it in there like that. So that's what we're going for, and this is the first step towards macros. And you can see that we can kind of use these operators as a template mechanism to produce code, which is what macros do. So first we're going to implement the syntax quote operator. So here's our prompt. Implement the back quote reader macro. When the reader sees a back quote character followed by any other expression, it should return a list excuse me, with the first element the symbol syntax quote and the next symbol the expression that followed the back quote character. So a back quote A would become syntax quote A, and a back quote 1, 2, 3 would become syntax quote 1, 2, 3. When the evaluator sees a list that starts with a syntax quote special form, it should return the rest of the list. All right, let's have a go at this and have it make the plan. Notice I haven't said anything about the unquote operator or the unquote splicing character, but we'll add those after this. We're starting from a fresh context, so it's reading everything. It's going to look at how we handled quote to do this, which is, it's very similar, so that's a good idea. And here's our plan. Okay, that's exactly what we're thinking. Add backtick to the token typing. Okay. In parse expression, add a case backtick. Okay, yeah. Eval. Okay. And our latest check undefined symbols. We're adding syntax quote alongside quote. Okay, exactly. Okay, let's do it. It's updated the lexer, it's updated the parser, and the evaluator. Okay, it's done. Let's give this a quick try. So we use backcourt 1, 2, 3, and we get 1, 2, 3, just like we did with quote. So let's go ahead and add the next one. Let's add the reader macro that works or the unquote. This one's kind of hard to. I'm going to borrow from my previous quote, I think. Yeah, that's not going to work. Add the reader macro that behaves just like closures macro. When the lexer sees when the reader sees a character followed by an expression, comma, it should return a list with the first element, the symbol unquote, and the rest of the list being the expression that followed the character. When evaluating a list that starts with the the syntax quote special form, any elements of the list following that is a list consisting of the unquote character and another expression, it should evaluate the expression and replace the entire syntax quote list with the result. For example, syntax 1 x3 would result in syntax quote one unquote x3, and when evaluated, assuming x is defined to 2, in would result in 1, 2, 3. If x isn't defined, we should, of course, get an error. Ask any clarifying questions you need to, but this should work like it does in Clojure. All right, I think that's a good enough prompt. I'm thinking ahead, so I'm wondering what unquote splicing does. Let's try the unquote splicing operator on a non-list. I think it'll just act like an unquote. No, we get an error. Okay, so it has to be a list. All right, that's interesting. Oh, here's a question that's asking, should unquote substitution be recursive? Walk nested list inside quote. Clojure does that. So I'm going to say yes. Should unquotes. Oh, okay. Let's go ahead and say yes. It's ahead of me. I'm going to go ahead and do this. Submit. All right. I think I said this before, but I think the Claude is doing pretty well in my prompts and kind of knows what I'm thinking ahead of time, because lots of people have done Lisps, implemented Lisp. There's Clojure itself, so it has a lot of training data on this stuff, and kind of knows what I'm doing already. I switched to plan mode. I don't know if that's going to matter. All right, here's our plan. Extend the syntax quote system to support full Clojure stack quasi-coding. The backtick reader macro, already implemented, produces syntax quote, but currently just returns this plan upgrade sent to recursively walk its form and substitute unquote and unquote splicing subforms. Behavior produces by okay. Add two no quotes for the Lexer, yes. In next token, yeah. In the eval, syntax quote expand. It is handling all this stuff. Updating check undefined symbol. All right, that looks good. I'm going to say do it. It's taking a while. Now it's finally running the tests. It's running the REPL to verify things. Looks like it worked. I'm surprised it didn't write any tests. Let's run our stuff and let's see if we got it. Well, let's define x to be 2 and let's do a splice. Alright, that's working. Let's define y to be the list 1, 2, 3, and then we will splice that in there. 1, y, 3. And that's right. So that looks good. I'm going to go ahead. I'm going to say write tests for syntax quote. Write tests for what we just implemented. That's kind of vague. I hope it can figure that out. So it's reading the tests. While it's doing that, I want to go back and test the error checking. So let's do a back quote without x defined and make sure we get an error, and we do. Good. Again, taking a long time. There are a lot of tests for it to go through. Okay, we got a Lexer test. Some parser tests. And now we're going to add the full pipeline tests. Okay, it says all the tests pass. Let's verify that ourselves. Okay. Let's go look at the code. Alright, start with the Lexer. We added new token types. And new code to get those token types. Lexer looks good. Let's look at the parser. Got new code for those 3 tokens. To parsing it, we're going to transform backtick into some sort of quote, unquote into unquote, and unquote slicing and unquote slicing. That's correct. And that's it there. And then the evaluator. In lists, we've got a new thing for when we see a syntax quote, we're going to call another function. We're just going to do it recursively. And our check undefined symbols now handles those new symbols. Okay, that looks good. Let's look at some tests. We got our Lexer tests. It's probably at the very end. I can't figure out how to do. I forgot my Vim movement codes. All right. Alright, it's capital G to get the end. Let's look at the parser tests. Making sure that everything gets transformed properly. And then we have the full pipeline. If we evaluate that, we should get that. If we evaluate that, we should get that. Okay. Everything looks good. So I'm going to check that in. We are done with these 3. So in the next video, we'll add macros, which is another kind of a little tricky, but it's actually not that hard. So until next episode, again, in the episode description, the show notes, whatever you want to call it, we've got the link to the repo, and we've got a link to buy me a coffee. So if you want to support this work, And please comment below whether you like what I'm doing, if you want to see something different, if you want to change my approach, whatever. So thank you.